Okay, chapter 21.4 resistor networks. What is the meaning of the networks in it? It means that we want to connect different resistors together in different form, maybe in series or maybe in parallel or the combination of them. Then when we form up this one, then we will say that network. Now, what do we want? Here we want to find out the combination of the resistor connected in series. We want to make the complicated network. For example, here we have two resistors. We want to combine them to be only one. This one, okay, this R, we will say that equivalent resistance. Okay, it means that the effect of R1 and R2 combine them together, the effect of it will be the same as the equivalent resistance R. Now, here will be the derive. And before everything, you should know that if they are connected in series, it means that we have only one way, okay, and one path for it to power it. It means that the current must be the common current. Common current means that they will have the same magnitude of the current and also the direction. It means that the current passed through R1 will be exactly the same as the current passes through R2. Of course, this one will also the same as the equivalent resistance. Once again, what is the meaning of equivalent resistance? It means that we will have the same currents pass through it, and also we have the same PD across it. Okay, now start the proving of it. Here, what is it? IR means that we have the input current I. We will have a equivalent resistance R. The effect of it will be the same as the original one. Original one means that we have two resistors. So this one will be the original one. IR1 plus IR2. What is it? This one will be the potential difference of it. V1 and V2. Combine them, we will have the total potential difference. So this one means that V1, this one means that V2. Combine them together should be V. Based on the Ohm's law, we know that V is equal to IR. Using this one, you can see that the common factor will be I, and I. So you can cancel it, we can get this one. This one will be the final result for it. If we connect two resistors together in series, then the equivalent resistance of it will be the addition of the value of them. It means that R1 plus R2. Add them together will be the value of the equivalent resistance. This one is the series circuit. But remember this one is not only true for two resistors. It is true for all resistors connected in series. Okay, this one. And next one is very important part. Division of the voltage. Division means that you want to divide it to separate the current, separate the voltage into 2 or 3. And we want to find out the relationship of them. Once again, because the resistors connected in series, it means that they have the common current, same current passes through it. Then larger resistor will have the larger potential difference. Okay, here will be the example. If R1 is greater than R2, then V1 should be greater than V2. Why? Because here V1 is IR1, V2 is IR2. But if this case is correct, R1 is greater than R2, then V1 should be greater than V2. And here will be the common current. We know that I should be V over R. R means that equivalent. V will be the total voltage. So if we want to use this one, the Ohm's law for the resistor R1, then we can see that I should be this. Put I here, you can get this relationship. Or you can write it down like that. What is R equivalent? Will be R1 plus R2. This one will be the ratio of it. How about this? Will be R2 over R1 plus R2. Okay. What is the meaning of it? It means that if I say that V is 6 volt, R1 is 1 ohm. No, 2 ohm. This one is 1 ohm. Then you can see that this one should be 2 plus 1. R1 is 2. So after your calculation, you can see that this one should be 2/3. 2 over 3 and then 6. After the calculation, you can see that V1 should be 4 volt. V2 will be 2 volt. Here, this one we will say that division of voltage. It means that if you know that R1 and R2, you can divide the voltage, the total potential difference, into 2, depends on the resistance. Then this one we will say that division of voltage. On the other hand, we have a parallel circuit. Parallel circuit, once again, what is the parallel circuit? They will have the same potential difference across different branches. Look at it. In the junction point A, current in should be equal to current out. It means that in is I, out will be I1 plus I2. And once again, for the parallel circuit, these branches, these two potential difference should be the same as this. Then all of them should be equivalent to V. What is V? Will be the potential difference for this one across equivalent resistance R. Once again, the input current should be the same. The potential difference should be the same. We want to find out the relationship between R equivalent and R1 and R2. So here, for the different branches, they will have the same potential difference. For the first path, I1 R1. For the second path, will be I2 R2. Now, using this relationship, total input current should be equal to the total output current. And then we arrange the term I1 using this relationship. I1 should be V over R1 here. For I2, okay, should be V over R2. And what's I? I should be V over R. And R is R equivalent. Then you can see that the common V, the total potential difference, should be the common factor. You can cancel it. Lastly, you can get this one. R equivalent should be inverse of R1 plus inverse of R2. Add them together. Finally, this one should be inverse of R equivalent. This one. And you should remember this relationship. Of course, in the public examination, will give you this relationship, this formula. And of course, if this one for two resistor, you can rearrange the term. This one should be R1, R2. This one should be R1 plus R2. But once again, this one is the inverse. Then R equivalent will be inverse of it. Then this one we can see that this one will be the product. This one will be the addition of them. 分子相乘，分母相加。And here will be a very important conclusion for it. The equivalent resistance R in parallel circuit must be lower than the individual one. This one is very important. For example, if this one is 2 This one is 3. Then what happened? Using the calculation, should be inverse of 2 plus inverse of 3. This one should be inverse of R equivalent. And then try to do the calculation. This one should be 6, this one should be 5. Then ROU equivalent will be 6 over 3. 6 over 5. 6 over 5 is around 1 point something. 1.2. 1.2 is smaller than 2 and also smaller than 3. Okay? And then you can see that for thinner cable, it will have a higher resistance. But why? Because this formula in the last session, rho L over A. Thinner one means that A is smaller, then R should be greater. Now, if you combine them together in a parallel, okay, parallel connection will be like that. You can see that R will be this one. This area A will be greater one. Then R will be smaller one. Okay. And similar to the last one, division of voltage, here we will have the division of current. It means that the input current can be divided into 2 branches, I1 and I2. But this I1 and I2 will be depends on the value of R1 and R2. But how to know that? What is the relationship? Using this one. They have the common V. It means that all the potential difference should be the same. And then try to find out current I. Current I should be common PD and then over R1. But what's the common PD? Common PD should be IR. And this R will be the equivalent resistance. Okay? And if like that, then what will happen? Actually, you can write it like this. What is R? What is R? R for this case should be the product of them over sum of them. Okay, this one. And then over R1. I. Okay, can you see it? And then now you can cancel R1. Finally, you can get this one. R2 over the sum of them. And once again, this one is the ratio of the resistance. And pay attention on the subscript. In order to find out I1, okay, I1 should be depends on R2. R2. Okay, what's the meaning? If R2 is greater, then it means that this I2 should be smaller. Then more current will pass through R1 instead of R2. So if R2 is greater, then I1 will be greater. On the other hand, if R1 is greater, then I2 will be greater. Because at the back end, V should be IR. R is greater, but V should be constant. Because common potential difference, then I should be smaller. Okay, this part is very important, especially for the multiple choice question. You just need to use the ratio, then you can get it. Okay, next one. Example 7. Here we have 3 different resistors, 1 ohm, 2 ohm, and 3 ohm. We want to find out the maximum resistance, and also we want to find out the equivalent resistance of them. How to get the maximum resistance? Very easy. You just need to connect them in series. 1, 2, 3. Add them together. The answer should be 6. Okay, part B. Here we want to find out the minimum resistance. It means that they should connect in parallel. Like that. 1, 2, 3. And then using the inverse. Okay, inverse of 1 plus inverse of 2 plus inverse of 3. Like that. Okay, our equivalent should be 0.545 ohm. This one must be smaller than individual one. Okay, smaller than 1, smaller than 2, and smaller than 3. Remarks here. The order of the resistance in series or in parallel combination does not affect the equivalent resistance. It means that if you want to change the order of them, for example 1 2 3, 3 2 1, 3 1 2, like that, all of them should be the same. Because here, when the currents pass through it, the charge will release energy. But finally, all the energy should be used. Okay, then if this one pass through 1 first, it will release less energy. If it pass through 3 ohm first, it will release more energy. But at the back end, at last, they will have the same energy consumption. So this one tells us that the order is not important. Okay, this one is the comparison between series and parallel circuit. Once again, for the series, common current. For the parallel, common voltage. Okay. You can look at this simulation. Okay, for this, like that. Now look at this one. Will be this one. Okay, for this will be this. You can see that the current are 3 volt, and the current should be 1A, and this here will be the division of the current. For this, you can see that the current will be 0.25. This one is the series circuit. Here is the combination of it. We have the current, total current will be 0.33, and then divided by 2, because here we have 2 branches. How about this? This one, the total current should be 0.6, and here we have 2 branches. For each of them should be 0.3, and then up to here. This one very important. For this part, you can see that for here only 2 paths, but actually here you should rewrite it like this. Here, this part you can think that these 2 should combine together and then divided by 3. Okay, so it means that here should be 0.3, 0.3, here will be 0.6, but here we have 1, 2, 3 branches. For each of them should be 0.2. Okay, you can see it like this. Okay, how about next will be the voltage. For the voltage, this one will be the division of the voltage. The total EMF will be 3 volt. For 2 identical light bulbs, we'll have half of it, 1.5 volt. For here, this one will be the parallel circuit. They will have the same potential difference. All of them will be 3 volt. The third one, this one seems to be quite difficult. Okay, but here in this chapter we will focus on it. Now look at this. What happened here? All the light bulbs should be the same resistance, but here we have 2 of them connected in parallel. Then you can use the calculation to find out the equivalent resistance of these branches. Here we can say that R, and R. In parallel circuit, what will happen should be 1 over R plus 1 over R will be equivalent resistance. Okay, R equivalent. Then you can see that will be 2 over R. Well, what is R equivalent? Will be R over 2. Here this 2 is very important. You can see that if R, both light bulb are identical light bulb, then they will have the same resistance. Then this 2 means that how many branches here will be 2. If here we have 3 light bulbs, it means that the 4th circuit, then you can see it, this one will be over 3 or over 4, like that. Then after your calculation, you can see that combine these 2 together will be R over 2. It means that 0.5 R. And how about this one? This one will be 1 R. Then you can see that the total resistance of it should be 1.5 R. For this will be the proportion will be 1 over 1.5. This one, it means that 2/3. Here the total EMF should be 3 volt. This part will be 2/3. Then finally this one will be 2 volt. Lastly this one will be 1 volt. This one will be the division of voltage. Okay, now chapter 9. Okay, look at this. True/false question. Resistor is equivalent to a network of resistors if its IV characteristics is the same as that of the network. The answer is yes. Okay. This one tells us that a resistor, it means that the equivalent resistance, okay, will have the same characteristics of all resistor connected in parallel or connected in series or the other combinations. Part B, the equivalent resistance of a series combination must be greater than the resistance of each individual one. This one, of course, yes, because we know that this one R equivalent. This one R equivalent should be R1 plus R2, like that. Then you can see that this one is the addition without any negative value. So combine them together should be greater than individual one. Okay. Next one. Part C. The individual resistance of 2 wires connected side by side. Side by side means that parallel must be larger than the resistance of each individual one. Yes. Okay. Now this one must be larger. This one is wrong. Must be smaller than individual one. Okay. Question number 2. Here we want to list out what's the PD in different connection of it. And now in this case you should know that the division of the voltage, because we want to focus on the voltage, the PD. Then what will happen? Try to find out the resistance of them. 100, 150 and 50. Add them together should be 300. 300 ohm in total. But this one will be 100. It means that this PD, potential difference across AB, should be only 1/3 of the EMF. 1/3 of the EMF should be 2 volt. How about this? 50. 50 over 300 should be 1/6. Then it means that this one should be 1 volt. How about 150? Should be half of it, 3 volt. Pay attention. 1 volt, 2 volt and 3 volt just only for the potential difference. Okay, not the potential. Here, usually for the negative terminal, we will say that 0 volt. This 0 volt will be the potential. This one, the potential will be 6 volt. Once again, this 1 volt just only potential difference, not the potential. Then look at D. Because from the negative terminal to D, this connected wire, we think that there's no resistance. Then there is no potential difference. D, the potential should be 0. But after our calculation, this one should be potential difference should be 1 volt. Then it means that C should be higher than 0, 1 volt. So C should be 1 volt. This 1 volt means that the potential at point C should be 1 volt. And this one, the difference is 3 volt. Then the potential at point B should be 3 volt higher than 1 volt. It means that the potential at point B should be 4 volt. Here, A is greater than B, 2 volt, then A should be 6 volt. After this, you can fill in this table. Look at this. We want to find out the difference is 1 volt. Then should be CD. What C? C is 1. D is 0. 1 and 0, the difference should be 1. Of course, yes. How about the difference is 6 volt? Should be A and D. Because D is 0, A is 6. So this one should be 6. Now for the other combination, you can try to find it out. For example, starting from A is 6, and then B is 4. Then the difference should be 2. Then here should be AB. How about the difference is 3? 3 will be 4 and 1. So this one should be BC. How about 4? The difference is 4. 4 should be 0. 2 should be 2. But here we can't find out any 2 volt. So this one should be boy dot. For 5 should be 6 and 1 AC. Then that's all. Okay. This one in this checkpoint question number 2, you should focus on the potential. Then using the potential, you can find out all potential difference. Okay, next, this one will be the parallel circuit. Well, once again, for the parallel circuit, you should pay attention on the branches. All the branches should have the same potential difference. For the negative one, 0. It means that this one should be 0 volt. For the positive terminal, should be 6. Then it means that here should be 6 volt. This one is 6 volt. This one also. This one also. So all the potential difference should be the same. A similar case, because all of them should be 6. Then this one is 20 ohm. Okay. Using the Ohm's law, V is equal to IR. 6 is equal to unknown I, and R, for example, here is 20. Then you can see that this current should be 0.3A. For this should be 30. Then this one should be 0.2A. Okay. Then for 10, this one 10. Okay. This one 10. Then this one should be 0.6A. And here we have 3 different switch. You can close it or open it. But once again, if you close it, the potential difference will also the same 6 volt. Okay. Then the current will be this. Otherwise, if this switch is open, then this current should be 0, because here is open circuit. Now look at this. If your answer, the current is 0.2, then it means that B should be closed only. You can see that this one. And then how about 0.3? Of course, should be A closed only. Finally, you can get this answer. What is 0.5? It means that 0.2 and 0.3, add them together. For 0.8 should be 0.2 and 0.6. For 0.9 should be 0.6 and 0.3.